Hello and welcome to the radio room. We're going to revisit the HP204C oscillator today, the power supply we've been working on for a little bit. It's been a little while since we've had a video out concerning this. Just been a little busy. Finally got a little time to get back in the radio room here and work on it. We're going to first off go over a little bit of the idea of what we're going to do to the power supply. Last video we breadboarded a circuit that would provide us positive 13 and negative 13 volt for the oscillator. We're going to be putting that circuit onto circuit boards, just some perf board, circuit board that I have to put inside the old power supply, 12 volt power supply that I had that was dead. I think I figured out a pretty good way to get it in there and a good way to make sure that we can still access the potentiometer so we can adjust it correctly. And so let's go ahead and take a look at it. So on the bench here, I actually have two boards here. This first board is mostly just the big filter capacitors. I don't have anything soldered on yet. This is mostly just a kind of a dry layout on the two boards. The only thing that's soldered in are the two voltage regulator ICs. So this is basically just going to hold the filter capacitors, the first filter capacitors that are coming off the rectifier. Got two screw blocks here. This one right here will be for the positive, negative, and center tap to come into our filtering. It'll come off of this board, come out of this screw block, and go over to our next board, which is primarily the regulator board. I did add the other two capacitors that will be in line after these big ones. I moved them over to this board. I had plenty of room on this board, but I wanted to get them closer to the regulator ICs, mostly because this board is going to fit in this area right here. They'll be standing up. I still have some work to do on this box before I can install everything, and still gotta get everything soldered onto the boards and whatnot. And then this board will actually mount back here using the ICs as support. So basically like that. Might move it over a little bit, but that's basically where that's going to be, and then it'll have two heat sinks that the ICs will actually screw to. That'll be on the back side of the board. The reason why I wanted to move these capacitors over closer to the regulator ICs is because of the distance between here and here is going to be about that far. It's going to be about 4 inches of wire going from the filtering here to here and running right by this transformer. There's going to be a lot of magnetic fields in there and stuff. I don't want anything to get reintroduced into the circuit from those two longer wires before they get to the regulator ICs. So these will clean it up again right before it gets to those ICs. Those ICs want as clean as possible. They don't want a lot of ripple. It'll make them work a lot better if they're not constantly having to adjust for variations in voltage. So this board, we have the two filter ICs, the same ones we had on the breadboard. These two resistors are part of the adjustment. They'll actually probably be soldered right onto the tabs. Let's see if you can see that. I still have the tabs pretty long right here. I'll probably leave them like that so that these can be, I'll trim the legs down and have them across the two appropriate legs right there. As you can see, nothing is soldered on except for the two ICs. Still have to run wires to do all the interconnections on the board, and of course on this one as well. The screw block right here will be our power output to the oscillator. So we'll have one side or the other will be positive and the other side will be negative, with the third one in the middle being our 0-point ground, if you want to call it. We'll come out of there, and I got some cable here. It's looks like it's 6 conductor. We only need 3. This is what I had. Like I said, this is a junk box power supply we're building. We're just using stuff that we got laying around the radio room. Found a grommet that fits real nicely. It's got just some tension on it. I'll of course have to drill a hole in the back of the box here and have that come out. Might put a little dab of super glue on there to make sure this can't slide in and out of the box. It's either that or I'll have to make sure the hole is definitely tight on that. On the box itself, still got some work to do on it before anything can be built. Of course, obviously got to drill 2 holes to mount the ICs on. I have to drill a hole for the power output. I kind of want to get rid of these holes on front. I do have a plug here that kind of fits, unless it turns and it falls right out. This is an oval. It's not actually a round hole. So I'm thinking I can probably pop that in there, get it straight. It's not going to quite cover all the oval. It covers most of it. Probably super glue it in place. These 2 holes here, I think I have a couple of more of these plugs that are a little smaller. I might have to drill these out. These are oblong, kind of an oval shape as well. Got 2 flat sides on them. Those were the binding posts were coming out, so that's where it keyed and locked it in. And I'll probably paint the box. I do have this color here. It's a desert sand. I'm thinking if you guys want to look at that color, and of course I don't know, this might not. Woo! Let's don't knock stuff around here. Not sure if this color. Let's see here. See if I can get a good angle here. This obviously was a lot different color a long time ago. It's gotten pretty yellowed. But I think the desert tan is going to kind of make it match this. Hopefully it'll look all right that way. Another thing I did notice, I don't know if this is lucked out or what, but our oscillator and our power supply are just about exactly the same width. So once this is painted, I think I can set it right on top of it and it's going to look pretty good. I don't think I'm going to mount it to it. You never know. Maybe. But we'll have the power, everything right there with it. This has pretty good shielding. I'm not too worried about this transformer putting anything into the oscillator itself from being that close. We'll have lots of shielding. This box is grounded down underneath here. Underneath here, you can see it does have a ground that's going to the electrical ground, so it's going to be shielded pretty good. But I got to clean this box up. Gonna have to do some unwiring over here so I can get the fuse holder out, the power switch out, probably take the transformer out, take the rectifier out. These 2 standoffs right here, I'm gonna have to get out of there so that the filter board can fit in there. I'll have to find some bolts, some screws, nuts, standoff something to mount that in there. Oh, another thing. I do have the cord here. This isn't going to just run into the back of the oscillator. This is the back panel, the power supply for the original system. I've basically stripped everything off of here. There's still some diodes, the rectifier diodes and stuff on here. Might remove those. They're pretty isolated. I think they're going to one of the pins on here. So I'll have to see what that is. I'll have to look at the schematic, find out if this is definitely going to have to come out of here or not. But in order to get this to plug into here, I don't want it just straight wired. It's just going to be awkward unless I definitely have this mounted. But I'm not sure I want to go that route yet. I want them to be separable if they need to be separated. So I need to have them plugged in to it. Originally I thought, well, I'll just take the original power cord that plugs into this right here and cut the end of it off, wire it up, and we're good to go. But I got to thinking, if somebody else ever needed to use this oscillator, and they grab that plug and they're like, oh, somebody just cut the end of it off or something, or they found another HP plug. Well, if they plug that in and it's plugged into line voltage, 115, 230 volts, or close to 120, 240 these days, they plug that in there, well, first off, it's probably not going to do anything because it's not hooked up to anything. But if I did, of course, that would be hooked up to the DC input on here. There's no transformer, there's no rectification, there's not been anything on this board. This is going to be going straight into the pins here that are supplying positive and negative 13 volts to this oscillator. Well, you put 120 volts or 240 volts AC into that, the only thing you're going to have is probably a spark show and a lot of magic smoke coming out. So I don't want to use that. What I'm going to do is I'm actually going to terminate the cable into a 4-pin microphone connector. Only need 3 of them, but for maybe something else. I'll come up with something else I need that one for. And here's a jack. It's pulled out of an old radio, probably an old CB, a Midland or something. It just about fits through that hole. I'll have to do a little modification right around in here to get that through there. As far as where that's going to come through on this board, I have to put this board back in here and tie my voltages into this, because that's where it gets into the rest of the oscillator. So I got to use this board. This actually just fits through here if it happens to stick back that far. There is a little space between this and that back panel, so I'll have to make sure I get it centered this way when I trim the panel back here after I get this out. Make sure it lines up right with that. Then I can come straight off of this and figure out which one of these pins. Like I said, I'll have to look at the schematic. Find out which one of these pins has the positive 13 volts, which one's the negative 13 volts, which one's the 0 volts, and tie them into here, and it'll feed it straight into the oscillator. So that's pretty much what we're looking at right now. Got the back panel, got the board, the box here. I'm just calling it the box. It's the old power supply. Got our circuit boards kind of laid out. If I can keep from knocking them off the desk, they might stay fairly laid out. We'll have the heat sinks on the back side of the box there. I'm going to keep these nice and cool. The box itself probably would be more than enough heat sink for these, but that's what I'm screwing the screws into. So if I have to screw the screw into something to hold it there and it's going to be a heat sink, well, it's even better. So I'm going to go ahead and work on this. Get the box ready, clean it up a bit, get it painted. Need to get these soldered and wired up. Get the holes drilled, of course, into the box. Make sure everything's good to go. It's going to be a little bit of work. Got a little bit of work ahead of me. Fortunately for you, it's only going to take a few seconds in the video. So we'll go ahead and let me get to doing that. and we'll see you here in just a few seconds as far as you'll know. Okay, and we're back. We've gotten a few things taken care of in the last few seconds from your perspective. About a day's work so far on my end. Just wanted to go over a couple of things before I actually put everything together. I'll probably put everything back together off the camera. A lot of intricate work to try and get this put back together. I do have one board that is mounted right now, mostly because I wanted to make sure I measured right. I'll go ahead and show you that board. This is the filter board, and it's mounted in there. You can see it. I'm not sure y'all can tell. It's actually mounted at an angle, kind of this way, just a little bit, and that's because I needed to make sure this was going to clear the edge here. The top slides down on top like this, so I wanted to make sure that it would clear that capacitor hangs over the edge of the board just a little bit on both sides. The box, I think, came out pretty good. Got the front done here. The paint didn't come out quite as good as I was wanting to. I actually used a different paint than what I had shown y'all before. This is actually Desert Tan, but it's the camouflage. The other stuff I had was actually for like vinyls and plastics, and I didn't know how great it was going to work on the metal here. I did sand down the paint that was on there to help it stick a little bit better. I think that's going to work pretty good. Let me get the oscillator over here, and we'll compare colors a little bit. I think it's going to be pretty darn close to the same color as the front. Now, mind you, I don't think this was originally this color. I think it had a sticker right down here. See if I can get that in the camera. Kind of a wider spot. So I'm pretty sure this was probably nearly white when it was first made. Do have the plugs in there. Got this one super glued in. It does have just a slight little opening right there where it didn't quite cover everything, but I did super glue that in there. Have the grommet in for the cable that we're going to put in the back. Already getting some scratches on my paint, and I'll put some rubber feet on this so that it can sit down quite well. Right now it's just sitting on a paper towel, keep from scratching it up too bad. Let's see, I did pull out the transformer, pulled out the switch, pulled out the fuse holder. I do have this board completed. This is the regulator board. It does have the two capacitors to help keep some of the ripple off the ICs. I did clean these, use some contact cleaner and kind of moved them around a little bit. I think it came out looking fairly well. Got a little crowded on the board in some spots. Getting these resistors in here and then running the output wires to everything. Just trying to keep everything so it's not touching anything. Got a little space between the wires. I'm getting everything soldered, so I'm getting down in there in between things. Got a little interesting. Got the output block here. Do have it labeled positive and negative, and the center, of course, will be the 0. And once again, that's going to mount. I do have the holes drilled for that. That's going to mount about right there. So when I put this together, I'll probably get all these boards in here, then drop the transformer back in, just to give myself some more room to work. This box doesn't have a lot of room. Drilling these holes right here were really fun. I had to mark them from the inside, and no way to really transfer it real easily to the outside, so I actually drilled them from the inside. Broke a drill bit, so there's a casualty in this project. So filter board, regulator board. These wires will come over here to the out. You probably can't tell, I wrote in right there, and on the tops of the board here, or on the tops of the I'm not really sure you can see that. I do have in and out, so these will be coming from the rectifier. These will go out to the regulator board. The cord will go through the grommet and be about right there is where it's gonna have to hook up. Like I mentioned in the previous part of the video, this was a 6 conductor, but I went ahead and paired them. So we got red and orange. I figured those two are pretty close colors. Would be our positive 13 volts. The green and the white will be our negative 13 volts. I've kind of following a color scheme through this whole circuit here. Red is our positive, green is our negative. Off the rectifier, it starts right there. We come over here, we do have green. You can see a green wire sticking out here. That's on the negative 13 volts. The red's on the positive. All the way over to here, red's going to be the positive, black is the 0 volts, negative is the green, negative 13 volts. And the same thing, any jumper wires in here follow the same scheme. So we follow the same wiring scheme the whole way through. We will have these mounted on the back here. These screws will be through here and actually hold this board to the back wall of the box. The rectifier will be back right here where it was. Here's the back panel. I wanted to show y'all. It doesn't look too bad. It's got a little space around the jack here. I just took a file and just barely had to take any off of each side, and it fit right down in there. Got it snugged down good, and we just got our 3 wires. I found the best spots to have each wire connect. This is where the original negative 13 would have come off the batteries. This is where the center tap of the batteries, the 0 volt reference, would be, and it comes down, and that actually goes to this whole big ground plane right here. And in the positive 13 volts, I just put where they had the final part of the output for the positive 13. So this pin right here the second one in. Let me see if I can find something to point a little bit better with. This pin right here is our negative voltage. The one right next to it is our positive voltage, and the one just to the other side of that is our ground. Got this mounted back in here, got the bolts back into it. I went ahead and left the switches in there. They don't do anything, they're not hooked up, but have one less hole that's going to be hanging out in the back of the box of the oscillator here. Went ahead and added another jumper back to ground here. That goes to this binding post. This binding post is just here so you can connect the circuit ground, or the 0 volts, to the chassis ground. Right now all this floats. The whole circuit floats as far as the oscillator, unless you have a jumper in here to make it actually go to the chassis ground. And that just depends on kind of what you're doing, if you need more shielding, whatnot like that. So, like I said, I just need to put everything back in here. It's going to take a little bit of time. Got to solder the switch back in. Got some really fine wires coming out of the transformer on the primary side here that I got to negotiate back in there. Get this through the grommet. It's going to make a pretty sharp turn there, and get it hooked up. And we'll be back here in just a little bit in the rest of this video, and we'll show it back together. We'll turn it on. Hopefully everything works right. I've double checked most of this. Unless I'm missing something, that circuit should be good to go. And we'll fire it up. We'll check the voltage on it, and try to make sure that everything's set right before it ever gets hooked up to the oscillator. So we'll see you in just a few minutes. We'll be right back. So here we are with the power supply completely back, reassembled, boards are installed. Everything's ready to go. It's basically just ready to turn on, and hopefully the magic smoke doesn't come out. I've looked over the boards pretty close, made sure that everything looks like they're the way they're supposed to be. So let's see if we can't turn this thing on and see, first off, that it doesn't cascade into a showering sparks and smoke, but we'll see what goes on. Assuming it survives the initial turn on, we'll check the voltage that's coming out of it. We'll probably have to do some adjustments on it. Probably hear a little beep in the background. I got a battery charging. It's the charger switching between float. We'll probably have to make some adjustments down in here with the two potentiometers that are mounted on that board. See if I can get the light right so you can see them. And there you go. You can see both of them right there. Those nice shiny brown discs. We'll see if we can't get the positive and negative voltage set to 13 volts. So I'm going to go ahead and plug this thing in. It is off. Let me go ahead and show you this thing before we plug it in. So we do have the board mounted in here. Our rectifier's mounted back in, the transformer's in, the fuse holder's in, the power switch is in. We got our inputs coming to right here to this block, like I mentioned before. We got the center tap of the transformer hooked up to that as well. Then we have our 3 wires that are kind of running underneath everything that are going out from the filter board over to the regulator board. Give you a different view of that. Got a few wires in there. Get this thing up here where you guys can really see it. Get some different light on it here. Sorry about bumping the camera there. I kind of did a little loop with the cable here. It was going to be a pretty awkward angle to come down and into those, so I just did a loop around and into the block there. Got all the wires are pretty much separated from each other. Some of them are a little close. Shouldn't be a problem even if they were touching, but I just like to have a little bit of space between them. So let's see if we can't plug this thing in, and we will check the voltage on it and make sure we got positive 13 volts and negative 13 volts. So let me go ahead and plug this in. Well, that's always a good sign. Nothing's blown up yet. And let's turn it on right now. Well, nothing seems to be doing anything adverse. So there's 2 possibilities. One, it's good, hopefully. 2, it doesn't work at all. So let's find out. I'm going to go ahead and hook my volt, my DMM up here. I'm just going to use the center tap here as our ground, since it's at the same potential all the way through the circuit. Do this carefully. I'll let that just kind of hang out there like that. Alright, moment of truth. Let's go to the positive 13 volts. I'm sure y'all can see the DMM reading here. want to get it in a spot where you're not going to be able to see the voltage while I'm doing this. I think you can see the voltage right there. Alright, so just first check here. Let's make sure it's actually doing something. So here's the positive 13 volts. Oh, we do have power. 12.55 volts. Well, while we're here, why don't we see if we can't get that to 13 volts. So I am going to go in here and adjust the potentiometer carefully until we have 13 volts. Kind of touchy. Whoop. Way too high that time. And 13 volts positive. Alright, let's see what we have on the negative rail. Negative 11.4342, somewhere in there. Kind of moving around. Let me get in here and see about turning that up. Oh, went past it. Oh, it is touchy right there at that 13 volt mark. Whoop. Wow, this is really touchy. I think we're going to call that good. Negative 13.03 volts. I think we're going to call that good. Okay, so it looks like it's working. Yay! Let me go ahead and turn this off. Get this stuff unhooked. So, at this point, we really just need to put the cover back onto it. We can hook it up to the oscillator. But I think I'm going to finish this part of the series with this. We've gotten the junk box power supply built. It's operational. One thing I'm probably going to do is put a smaller fuse into this. The original fuse is still in here, and that was when this thing was running a 4 to 6 amps output, maybe 6 to 8. So that fuse is a lot bigger than we need. We're only going to be pulling, I'm thinking, less than 100 milliamps out of this thing running that oscillator. The wiring in here, the IC, regular ICs, the ICs are rated at 1.5 amps. The wiring in here, this is 22 gauge, should be good to at least an amp and a half. So I'll have to do a little bit of figuring here, find out what kind of current is going to be on the input side in order to determine what size fusing in here. I'm thinking a 1/4 amp would probably be sufficient to run it. A 1/4 to a 1/2 amp fuse would probably make it so it's a lot safer. If anything fails in here, if possibly something fails in the oscillator itself, that fuse will still blow before things are catastrophically damaged. So we'll go ahead and leave it right there like that. I'm going to get the cover put back on this thing. We'll have one more portion of this video series after this. With this ready to go, we'll have it hooked up to the oscillator, and we'll do an alignment as much as we can on the oscillator. I did, if you remember a few videos ago, I did go through and just because I was bored, I decided to try and do an alignment on there. That's when I found out the voltages were all wrong. Well, I did align it, but that was with those other voltages, and I'm thinking that might make a little difference on how things are aligned in there, especially with the bias. So we'll go through there and we'll set the bias on the oscillator. We'll make sure that it's on frequency. I don't have a distortion meter, so we won't be able to check distortion, but we'll run through as much of the calibration of the oscillator as we can with what I have around, and that'll be the next video. And that, I believe, we'll finish the HP204C audio oscillator series. Kind of turned into a longer series than I thought it was going to, but then again, I didn't know we were going to have to build a new power supply. I think this was a fun project. I had a lot of fun building it, kind of figuring it out. Not sure if this is going to be sitting on top of the oscillator or if the oscillator will be sitting on top of it. I got to kind of play with that a little bit. Since they are the same width, I just think it's going to look so cool if they're stacked, one way or the other. And the color is really close, so it's going to look like it's supposed to be like that. So I hope you've enjoyed this so far, some of the steps of going through developing and building this power supply and trying to get an old oscillator to working correctly. It's not a traditional restoration of the oscillator, but I think this was fun. And let me see here. What did I actually buy to put this together? The little screws that are holding this board, I had to buy those. I didn't already have those in the radio room. Of course, I used new heat shrink, but I already had that in the radio room. I already had the rectifier that actually came out of this power supply, which is one that I'd actually replaced in the past. Really, everything that is in this power supply is stuff that I had in the radio room. So this is a actual junk box power supply. It might be referred to as junk box, but it's never junk. Like I said, you never know you need it till you throw it away. But fortunately, I hadn't thrown any of this stuff away. So we'll see you in the next video. We'll get the oscillator fired up. We'll probably hook it up to the frequency counter, probably the oscilloscope, take a look at what the waveform looks like. Hopefully everything still looks good on that. Just might have to make some adjustments because it's going to have, first off, a better balanced input and the correct voltages. I'm not really sure how that thing was running at 26 volts on the B plus and negative 26 volts on the B minus, and still survived. I guess that's just a testament to the way HP built things back in the 60s. One thing to note, I did find, and I don't think I have it sitting around here, I think I put it somewhere. I did find one of the capacitors that was on the back panel power supply that was in there. and just trying to get a date on it. It was actually marked 1969. So that oscillator is probably could have been built in 1969, but I think it's probably early 1970s. So, you know, just kind of narrowed that date down a little bit. I'm pretty sure it's probably real early 70s is when it was built. Probably hasn't had anything done to it, maybe an alignment here and there. But that's that. We'll come back in the next video and we'll do an alignment on it and wrap up the HP204 oscillator series. Thanks for watching. I hope you enjoyed these videos. If you do, give me a big thumbs up. And subscribe if you're not already subscribed. Maybe I can build a little bit of followers and make a little bit better videos in the future. Bye for now.